Hi everyone, welcome to this topic, the MAC address table, media access control. The first point is switch fundamentals. Now that you know all about the Ethernet MAC address, it's time to talk about how a switch uses these addresses to forward or discard frames to other devices on a network. If a switch just forward every frame it receives out all ports, your network will be so congested that it will probably come to a complete halt. A Layer 2 Ethernet switch uses Layer 2 media access control address to make forwarding decisions. It's completely unaware of the data protocol being carried in the data portion of the frame, such an IPv4 packet, an ARP message address resolution protocol, or an IPv6 ND packet. The switch makes its forwarding decision based solely on the Layer 2 Ethernet MAC address. An Ethernet switch examines its MAC address table to make a forwarding decision for each frame, unlike legacy Ethernet hubs that repeat bits out all ports except in the incoming port. In the figure, the 4-port switch was used for power on. The table shows the MAC address table which has not yet learned the MAC address for the 4 attached PCs. Note: MAC addresses are shortened throughout this topic for demonstration purposes. Okay, this is the MAC address. It contains the port, the number port, and the MAC address. And this portion is the MAC address of the PCA, PCB with this MAC address, and so on. The switch MAC address table is empty. Note: the MAC address table is sometimes referred to as a content address symbol memory (CAM) table. And content address symbol memory. While the term CAM table is fairly common, for the purpose of this course, we will refer to it as a MAC address table. Okay. Switch learning and forwarding. The switch dynamically builds the MAC address table by examining the source MAC address of the frames received on a port. The switch forwards frames by searching for a match between the destination MAC address in the frame and the entry in the MAC address table. Click the Learn and Forward buttons for an illustration and explanation of this process. The first tab is Learn. Examine the source MAC address. Every frame that's entered a switch is checked for new information to learn. It does this examining the source MAC address of the frame and the port number where the frame entered the switch. If the source MAC address does not exist, it's added to the table along with the incoming port number. If the source MAC address does exist, the switch updates the refresh time for that entry in the table. By default, most Ethernet switches keep an entry in the table for 5 minutes. In the configure, for example, PCA is sending an Ethernet frame to PCD, the table shows the switch adds the MAC address for PCA to the MAC address table. Note: if the source MAC address does exist in the table but on a different port, the switch treats this as a new entry. The entry is replaced using the same MAC address but with the more current port number. MAC A sends an Ethernet frame, and next step is the switch add the port number and MAC address for PCA to the MAC address table. Okay. Destination MAC address is 000D, source MAC address is the host A, and the next data is empty. The next step is forwarding. Find the destination MAC address media access control. If the destination MAC address is a unicast address, the switch will look for a match between the destination MAC address of the frame and an entry in this MAC address table. If the destination MAC address is in the table, it will forward the frame out the specific port. If the destination MAC address is not in the table, the switch will forward the frame out all ports except in the incoming port. This is called an unknown unicast. As shown in the figure, the switch does not have the destination MAC address in its table for PCD, so it sends the frame out all ports except port 1. Note if the destination MAC address is a broadcast or multicast, the frame is also flooded out all ports except in the incoming port. The destination MAC address is not in the table. The next step, the switch forward the frame out all other ports. Okay. The next point is filtering frames. As a switch receives frames from different devices, it's able to populate its MAC address table by examining the source MAC address of every frame. When the MAC address table of the switch contains the destination MAC address, it's able to filter the frame and forward out a single port. Click each button for an illustration and explanation of how switch filter frames. The first tab is PCD to switch. In the figure, PCD is replying back to PCA. The switch sees the MAC address of PCD in the incoming frame on port 4. The switch then puts the MAC address of PCD into the MAC address table associated with port 4. The switch adds the port number and the MAC address for PCD its MAC address table. Okay, this is the table. It only have the port 1 with the MAC address of PCA and have the next host is attaching the port 4 with this MAC address. And switch to PCA. Next, because the switch has destination MAC address for PCA in the MAC address table, it will send the frame only out port 1, as shown in the figure. The switch has a MAC address entry for the destination. The next step, the switch filters the frame, sending it only out port 1. And PCA to switch to PCD. Next, PCA send another frame to PCD, as shown in the figure. The MAC address table already contains the MAC address for PCA. Therefore, the 5-minute refresh the time for that entry is reset. Next, because the switch table contains the destination MAC address for PCD, it sends the frame only out port 4. The switch receives another frame from PCD and refresh the time for the MAC address entry for port 1. The switch has a recent entry for destination MAC address and filters the frame, forwarding it only out port 4. Okay, in this last step, only the communication is between host A and the switch with host D. The host D. And a switch can have multiple MAC addresses associated with a single port. This is a common when the switch is connected to another switch. The switch will have a separate MAC address table entry for each frame received with a different source MAC address, and send the frame to the default gateway. When a device has an IP address that is on a remote network, the Ethernet frame cannot be sent directly to the destination device. Instead, the Ethernet frame is sent to the MAC address of the default gateway router. Click play in the figure to view a demonstration of how PCA communicates with its default gateway. Note: in the video, the IP packet that is sent from PCA to a destination on a remote network has a source IP address for PCA and destination IP address on the remote host. The returning IP packet will have the source IP address of remote host and the destination IP address will be that of PCA. And activity switch it. Determine how the switch forward a frame based on the source MAC address, the destination MAC address, and the information in the switch MAC table. Answer the question using the information provided. Okay, frame, preamble, destination MAC, source MAC, type or length, frame, and or frame. Okay, in this example, the source MAC is the host 0A is here, and the destination is the host with the MAC address 0B. Okay. MAC table only register the port fast Ethernet 9 is attached a hub. And question 1. Where will the switch forward the frame? In all ports connect is fast Ethernet 1, fast Ethernet 3, fast Ethernet 5, fast Ethernet 7, and fast Ethernet 9. Okay, no, only fast Ethernet 7. And when the switch forward, the frame switch statement are true. Switch adds the source MAC address, known frame is broadcast frame and will forward to all ports. Okay. Um, Question 1. The ports that you select are not correctly. Okay. Okay, switch add the source MAC address which is currently not in the MAC address table. Mm, okay. Okay, show me. Okay, new problem. In this example, source MAC address in the host 0C and the destination MAC is 0B. Okay, attach port fast Ethernet 3 and fast Ethernet 5. Okay, only fast Ethernet 3 and this check. Frame is a unicast. Okay, correct. And finish with Ethernet switching summary. What did I learn in this module Ethernet? There is no official local area network standard protocol, but over time, one technology, Ethernet, has become more common than the others. Ethernet protocols define how data is formatted and how it's transmitted over the wired network. The Ethernet standard are specific protocols that operate at layer 2 and layer 1 of the OSI model. Ethernet has become a de facto standard, which means that it's the technology used by almost all wide local area networks. AEEE maintains the network standard, including Ethernet and wireless standard. Each technology standard is assigned a number that refers to the committee that is responsible for approving and maintaining the standard. The 802.3 Ethernet standard has improved over time. Ethernet switch can send a frame out all ports, excluding the port it was received from. Each host that received this frame examines the destination MAC address and compares it to their MAC address. Its Ethernet NIC network interface card that examines and compares the MAC address. If does not match the host MAC address, the rest of the frame is ignored. When it is a match, that host receives the rest of the frame and the message it contains. The next tab is Ethernet frame. Ethernet is defined by data link layer 802.2 and 802.3 protocols. Ethernet supports data bandwidth from 10 megabytes per second up to 100 gigabytes per second. AEEE 802 LAN-MAN protocols, including Ethernet, use two separate sublayers of the data link layer to operate: LLC and MAC. LLC is Logical Link Control and Media Access Control. LLC sublayer. This EAAA 802.2 sublayer communicates between the network software at the upper layer and the device hardware at the lower layer. It places information in the frame that identifies which network layer protocol is being used for the frame. This information allows multi-layer through protocol, such as IPv4 and IPv6, to use the same network interface and media. MAC sublayer. This sublayer IEEE 802.3 and the last protocols, for example, is implemented in hardware and is responsible for data encapsulation and media access control. It provides data link layer addressing and is integrated with various physical layer technologies. Data encapsulation includes the Ethernet frame, Ethernet addressing, and Ethernet error detection. Ethernet LANs of today use switches that operate in full duplex. Full duplex communication with Ethernet switch does not require access control through CSMA/CD. The minimum Ethernet frame size is 64 bytes and the expected maximum is 1518 bytes. The fields are preamble and start frame delimiter, destination MAC address, source MAC address, type or length, data, and FCS. These include all bytes from the destination MAC address field through the FCS field. The next tab is Ethernet MAC address. An Ethernet MAC address consists of a 48 bits binary value. Hexadecimal is used to identify an Ethernet address because a single hexadecimal digit represents 4 binary bits. Therefore, a 48-bit Ethernet frame address can be expressed using only 12 hexadecimal values. A unicast MAC address is the unique address that is used when a frame is sent from a single transmitting device to a single destination device. The process that a host uses to determine the destination MAC address or associated with an IPv4 address is ARP, Address Resolution Protocol. The process that a source host uses to determine the destination MAC address associated with an IPv6 address is ND. The features of the Ethernet broadcast are as follows. It has a destination MAC address of this type in hexadecimal 48 ones in binary, and it flows out all Ethernet switch ports except in incoming port, and it's not forwarded by a router. router. The features of an Ethernet multicast are as follows. There is a destination MAC address of this example when the encapsulated data is an IPv4 multicast packet, and a destination MAC address of this 33 and 33 when the encapsulated data is an IPv6 multicast packet. There are others reserved multicast destination MAC address for when the encapsulated data is not IP, such as STP and LLDP. It flows out all Ethernet switch port except the incoming port, unless the switch is configured for multicast snooping. It's not forwarded by a router unless the router is configured the router multicast packet. And the last tab is a layer 2 Ethernet switch. Use layer 2 MAC address to make forwarding decisions. It's completely unaware of the data protocol being carried in the data portion of the frame. An Ethernet switch examines its MAC address table to make a forwarding decision for each frame. The MAC address table is sometimes referred to as a CAM table, CAM table. The switch dynamically builds the MAC address table by examining the source MAC address of the frames receiving on a port. The switch forwards frames by searching for a match between the destination MAC address in the frames and an entry in the MAC address table. If the destination MAC address is a unicast address, the switch will look for a match between the destination MAC address of the frame and the entry in its MAC address table. If the destination MAC address is in the table, it will forward the frame out all the specific port. If the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. This is called an unknown unicast. And a switch receives frames from different devices. It's able to populate its MAC address table by examining the source MAC address of every frame. When the MAC address table of the switch contains the destination MAC address, it's able to filter the frame and forward out a single port. A switch can have multiple MAC addresses associated with a single port. This is common when the switch is connected to another switch. The switch will have a separate MAC address table entry for each frame received with a different source MAC address. When a device has an IP address that is on a remote network, the Ethernet frame cannot be sent directly to the destination device. Instead, the Ethernet frame is sent to the MAC address of the default gateway, the router. And finish with Webster reflection. Mercy and Vincent had no idea how their small business network operates. It's not much more complicated than my own home network. I did not realize there were protocols that ensure how my devices interact with each other and with the internet. Think about how home router. Think about your home network or the network at school or work. Do you understand the difference between your device IP address and its MAC address? How does this knowledge help you better understand how your network operates? And Ethernet switching quiz question 1. What is encapsulated into the data field of an Ethernet frame? This is the layer 3 PDU. And question 2. What is the length restriction of the data field in an Ethernet frame? Between 46 to 1500 bytes. And okay, is this or this? I say this is. Refer to the exhibit. What is the MAC address of this computer? Physical address. Question 4. Which Ethernet sublayer is used to control network access using CSMA-CD? That is the layer MAC address media access control. Question 5. What addressing information is recorded by a switch to boot its MAC address table? The source layer to address of incoming frames. Question 6. What important information is examined in the Ethernet frame header by a layer 2 device in order to forward the data onward? That is destination MAC address. The next is what happened to round frames received by a Cisco Ethernet switch. The frame is dropped. What is indicated by the 100 in the base 1000 base T standard megabits per second. Which three fields are found in an 802.3 Ethernet frame? Source, frame check sequence, and destination physical address. Match the components in the notation 100 base T to the specification. Category base is baseband transmission, T is twisted pair cable, and 100 is speed in megabytes. And which two characteristics describe Ethernet technology? It's supported by a IEEE 800.3 standard, and it uses unicast MAC address to ensure that the data is sent to the appropriate destination. And what will a host on an Ethernet network do if they receive a frame with a unicast destination MAC address that does not match its own MAC address? It will discard the frame and submit, and you have scored 100%. Congratulations, you have passed the test. Okay, well, this is all for this. See you in the next topic.